Hello, I'm Ashutosh Mishra. This is my submission to the task 2 for the internship application. So in this task, we have to build a self-healing classification DAG and with a fine-tuned model. We have to fine-tune a model on a text classification data set. It can be anything like sentimental analysis. So for this, I have chosen IMVD dataset and I have fine-tuned the Dilbert model on this IMVD dataset. And then I use fine-tuned model to build this uh, self-healing classification. So with human in the loop. So in this notebook, I have fine-tuned the distant bird model on the IMVD dataset, and then I have published the model to the Hugging Face Hub, and then this model is used in rest of the R workflow. The model is pushed to the Hugging Face, and these are the final metrics of the fine-tuned model. Now, moving to our main part. So the first thing is models.py. So in this script, we define basically the main essential input to the nodes. So there is a data class. This is we made a classification result. So this classification result, what is it? Structured all the classification result. Like if we provided we pass some input text to the our fine-tuned model, it results some label like confidence in our scores, everything, and we have to do logging as well. So we store the timestamp extra thing also. So so that's why we created this classification result to track and to structure all the classification result. And this workflow state is very important because this state is a input to each of the node. So it is like a state management for all the line graph workflow. So all the nodes we will define the line graph workflow. Take this state as an input, go through each of the courses depending on their node, and then at the end make changes in some of these states, and then this particular state pass on to the next next node or next basically condition depending on our workflow structure. So by workflow state, like we use the type to define also the type of these like labels we all got. Okay, so this is models.py, then nodes.py. So what our node looks like this. We structure this first. So yeah, so our node looks like this. There is an input text, then this input text goes to an entry point router. Entry point router is nothing but is a line graph based like routing. We can say it is a like a method in the it is a function actually. It is a function in the line graph which routes the input text depending upon our workflow design. So again, in this text classification workflow, we first initialized init method, then there is a load model which loads the R model, loads the tokenizer. Those are fine-tuned model from the Hugging Face. Models are fine-tuned model and tokenizer and all this. This is some for the exceptional handling and logging. Then there is the first node that is inference. So this inference node takes a state as our input that we defined earlier, and the workflow state actually it runs the classification, takes the prediction. And this is for and then the prediction got stored to the classification result class that we defined in the models.py. Then this is logging, and again at the end of this node we make some changes in the state, like we added the prediction and the message. So for the logging, for the display on the command line, and this is for the exception handling. Then there is another node that is confidence check. So in this confidence check node, we evaluate the confidence of the model prediction. So we set some threshold. If the model prediction is less than that particular threshold, then another node that is the fallback node gets triggered, and if not, we finally print the final result. So again, we also did the logging of this fallback trigger part, and if it is not else, then we will return the prediction. And what does the fallback node does? it acts like a human in the loop. So it asks for the clarification, like whether the review is the response I gave is positive, or it might is my response is correct or not, actually, if I frame it well. So it asks. It also suggests a label uh, different from the label the model predicted. So if the model has predicted positive, the confidence of less than 75%, so it will suggest a label like was this actually a negative score, and uh, answer ask user to answer yes or no. This is logging, and then we also put some clarification message. This clarification type yes, what should we do? Actually, the command line should display final label as the suggested label. If it is no, then the original label. So on. If any other input, then so this is then corrected result. This again we basically take the classification data and take the new and to store, so that we can display even after showcasing the user human improved feedback. We can showcase the confidence level of the model. Then there is a build workflow. So this is the important part. So it builds the LangGraph workflow with clarification. So the entire workflow is built using this. So here it inherits state graph. State graph is the fundamental, we can say, method of the LangGraph. So in this workflow, especially state graph is used to build workflow. So we can add nodes, we can add routing, we can add conditional routing, we can adjust. So these are some of the nodes. We define 4 nodes. Actually, we can add these nodes. Then we can also add an entry point router defining router state, and here we add entry point router. We add edges, like this is like where we routes the uh, where we basically check stops and check whether the condition got fulfilled or. Then this is a fallback. Again, then at the end we compile the entire log. So this is notes.py. Then we comes to logger.py. So in the logger.py, we simply get all the logging thing, and we save it into a single file classification log. Then command line interface. So what this command line interface, that it present a interface, a beautiful interactive interface for the user, and we also use the rich library to beautify the complete interface, adding the colorful boxes and also this all things. So this is simple. All the functions are true. And the main function starts here. The main workflow, the main group is it. So here the main function thing happen here. So these are the final thing. Then the interactive mode. So this is now, let me demonstrate the project. So let me run our main file. In the main file, we also put some demonstrated mode, like for demonstration, the initial example. So the initial example here was okay. The model predicted the confidence score of 68. It is a negative. Actually, it sound positive for me. So I say the model suggested label is correct. So I will say yes. So the final R label should be positive, and these are the confidence score predicted by our point. Now we can ask another question. I have also added put some questions like for the to be. Let me ask for this question. So I love hating every minute of this disaster. The model predicted with confidence score of 59 negative. So I think the model is correct here. The model predicted output is not correct. So actually the sentiment of movie is negative. So I can say the model suggested label is not correct. So it is no. So again, the final label is negative. We can also for another example. So in this, the model prediction is 92% positive, and Actually, here this is sarcasm. So the our fine-tuned model misses that. We can even try out. Last one. So again, it is a poster, and we can exit the command line interface either by Q, by typing exit, or quit. So we can exit it. Thank you.